Guys, today we are going to see the Unit 5 volume integral and their problems also. Last class we had seen the surface integral. Today we are going to see the volume integral. So volume integral is an integral which is to be evaluated over a volume bounded by a surface is called as a volume integral. You know that volume is basically it's a capacity is called as a volume. So for example, we know that that is a cuboid, that type of things, that is a sphere, that is called the three-dimension figures. These are all called as the volume figures. That is, it has the capacity. Suppose if it is a cylindrical water bottle is in the shape of the cylindrical shape. If you are taking, we can pour some water in that, right? We can pour some oil in that. So it is just like a container. It has a capacity. So it is called as the volume. It is called as the volume. Likewise, for example, cube, for dice also, it has a three dimension. So it is comes under the volume. Suppose it is in the format of the cube, boxes will be there. In that, or ice cube will be there. Ice cube means water is there, or any boxes like cube shaped boxes also we can put some toys or something in that. So it is just like a container. So it has a capacity. So that is called the volume. So how much it occupies the space, that is called the volume. So basically we know this all those things. So here we are going to see the integration in the volume, how the integral plays on the role in the volume in the space integral, that is we are going to see. So the volume integral is denoted by triple integral v and the function as well as dv. So the volume integral of f of x comma y comma z over v is denoted by triple integral of f of x comma y comma z dv. Suppose the function is given as f1 plus f2 plus f3. They have splitted like this and they have given means with the vectors. So we have to split like this in the format triple integral of this being I vector into f1 dv plus j vector into triple integral f2 dv plus k vector into triple integral v of f3 dv. So we have to use this method. Let us see the first problem. Evaluate triple integral over v del dot a vector dv, where a vector the function they have given and v is a volume enclosed by the cube they have given, and xy is the three variables are lies between 0 to 1 I have given. So directly they have given the limits 0 to 1. So no need to find anything in the question itself they have given. And they have given the function that is a vector equal to they have given. And they are asking us to find del dot a vector into dv. So first we should find del dot a vector, and then you can use a triple integration. You can use the limits to finish the problem. So del dot a vector, we know that del formation is or formula is I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. So a vector they have given us this one. So now dou by dou z of, dou by dou x, not z, dou by dou x of x squared plus dou by dou y of y squared plus dou by dou z of z squared. Now we are going to integrate with respect to x, integrate with respect to y, and integrate with respect to z. So if you are having, so 2x plus 2y plus 2z will come. If you are taking 2 outside, then x plus y plus z will come. Now in the place of the given question, we have to write triple integral over v 2 of x comma x plus y plus z into dv. So for this integration, we have to apply the limit 0 to 1, 0 to 1, 0 to 1. So x plus y is z into dv is dx dy dz. So 2. Then as usual integration we are doing. First we are doing the dz and then dy, then dx. So finally we are getting the answer as 3. So as usual integration only. Next problem, evaluate triple integral over v a vector into dv, where a vector they have given, v is the octant of the sphere they have given, and one more values they have given that for finding the limits. So v is the octant of the sphere. So we know that the sphere, how it will be. So if you consider, if you just imagine the globe how it will be, it's a sphere only, spherical shape only. So we have to see the octant. Octant means we have seen that the first quadrant, second quadrant, in the line integral we had seen a surface integral, we have seen the octant. Likewise here also v is octant of the sphere we are choosing. So and they have the limits x plus y square plus z square equal to 4. We are going to use it that. It is lies on the octant of the sphere. So this is the octant they have given. And then x is greater than 0, y greater than 0, z greater than 0. And they have given the as usual function a vector they have given. So here we are going to split the a vector into I into a1v plus j into a2v plus k into a3v. Likewise we are given. Because in the question, like the previous problem, they didn't give del dot a vector or del cross a vector. They didn't give any formation to evaluate. Directly they have given that triple integral over A vector into dv. So we have to split in this case only. So triple v into xy I vector minus z j vector plus k vector into dv. So we know that as per the definition, we are splitting I into triple of xy dv plus j vector into triple v of minus zx dv plus k vector into triple v of dv. Now separately we should do everything, and then finally we can apply in the given thing. That is, now see, triple integral over v xy dv. This can be written as triple integral over v xy into dx dy dz. Now for this we are considering the xy dv. Okay, so obviously the z term won't come. So z equal to, so we are taking the x value is 0 to 2. See here, x value is 0 to root of, see here, this is x, please change it. X is equal to 0 to root of 4 minus y square minus x square, because they have given the x square plus y square plus z square equal to 4 they have given. From that we are finding this value, and for y value we are omitting the x. So we are taking, for y if you are taking, we have the y minus 4 minus z square, and for z we are omitting both y and z, so we are getting 2. Okay, so we are taking that value. So if you doesn't understand, I will tell you. See here, if you are taking z squared, means z squared equal to 4 minus x squared minus y squared will come. So z equal to root of 4 minus x squared minus y squared. Likewise y squared. So first we are taking the z squared only. So z squared we have taken. So root of 4 minus y squared minus z squared. Then for y squared you can omit the x squared. For z squared both x and y you can omit it, because I vector we are choosing. I vector choosing now, only we should see only the x part only. For j vector we can see only the y part, and k vector only see the z part, remaining just eliminate it. Likewise only we are doing. So then as usual we have to do, first we are doing the x. So dx we are integrating with respect to x we are doing. So x squared by 2 into y dy dz. So for this we are applying the limit and write it. Second one y we are doing, then dz we are integrating, we are getting the answer. Okay, so for this we are getting 32 by 15. Likewise we can move for the zx, second term zx dy. Okay, and for that also 32 by 15 will come. Okay, for third if you are choosing, for that integral triple integral over v dv v, because they have given the, in the question they have given the only k vector alone, not any variables, not any coefficients are coming in this term. So see the third part, triple integral over dv equal to v. So v is the volume of the sphere they have given in the octant, and limits also they have given. So we know that the formula, that is here 1 by 8 into volume of the sphere we are doing. So 1 by 8 we are using for the sphere. It has sides, 8 sides it has, upper, that is bottom, top, and then here 4 sides will come. So 6 plus 2, 8 sides will come actually. 6 sides plus top and bottom. So 8 sides. So 1 by 8 into volume of the sphere. Volume of the sphere formula is, we know that 4 by 3 pi r cube. So here the radius we are taking as 2. Radius of the sphere is 2 we are taking. So 4 by 3 pi into 2 cube. So after cancelling we are getting the answer 4 by 3 pi. So now the given question you can write, first one 32 by 15 into I vector minus, this is in the minus format, so minus 32 by 15 into j vector, plus the third term is 4 by 3 pi into k vector. This is the answer. So these are all the two important questions. Suppose in the first question del dot a vector, in some cases we can ask del cross also. We know the del cross a vector, that is a determinant we will use, right? Del cross a vector. Curl you know very well. Del cross a vector, you have to put the determinant, and as usual you have to do the same only. Okay, in some cases only they may be asking, but it's not compulsory to ask the same del cross A. Mostly this type of questions will come, okay, for the volume integral. So thank you so much for watching. If you have any doubts, please approach me.